All right, so CAD project 11, we got some gears, uh, polar array, rotating copy shapes, chain dimension radius, use temporary line to locate dimensions 15 sixteenths. All right, so, you know, by now, we know that we're going to start most of our drawings unless we're given absolute coordinates uh, with the center line, right? So you can start by, doing the stuff that you know. This one has uh, a 1 and an eighth diameter. So some of us, I saw you using your calculators, your phones, if you want. You can pop open the calculator here. Where are you at? Oh, geez, it's on the other screen again. All right, so if you do that, it should pop up. I have two monitors. I gotta I don't know, that's a problem for another day. But right now on the other one, I'm dividing, 1 by 8. You should start to know that it's 0.125. But if you get stuck, you got to do the division. 0.125 is 1/8, eighth, sixteenths. Those things all come up over and over, especially in this type of stuff. So I'm escaping out of the calculator. It's on my other screen though, so I don't have to keep getting YouTube up or anything like that. So I'm going to start circle. Since it's a radius, it's going to default 1.125. All right, so that's my center circle. Then they give me some, you know, they give me some offsets that I can do. They give me some other circles. I'm going to do some polar stuff first, and they give me some dimensions for that. So we got a 1 and 3/8 circle. So I'm going to, I can multiply my 1/8 by 3, or I can just redivide 3 divided by 8, or I could start to know to memorize, especially if you're going to work with something like this. These 8 sixteenths, they come up all the time. It's good to know what they convert to as decimals. But so for 3/8, 375. So circle, center. The radius is 1 and 3/8, so 1.375. Enter. All right. So now, like, I know you guys are always saying, "Oh, the circle doesn't look right. Looks too small." Um, so you can only tell that if it's like relative. You draw a two, this one shouldn't be that big. Now it looks like everything's wrong. So I don't know what I'm doing over here. Not everything though. Just like keep that. All right. So I'm gonna erase those. Erase these. Circle E. Okay, center point. Circle E. 1.125. Good. Circle. Regular circle. Diameter 1.375. All right. Now relative, they look okay. So that's what the relative thing is. All right. So we got 3/8 diameter, 4 holes. So we got this intersection right here. Circle, intersection, D. 3/8 is 0.375. And then we're going to polar, so array, enter. We want a polar array. We want to pull it around there. And then they're evenly spaced and good. We have those circles. Okay. So, different things we could do. We can, let's do the teeth, I guess. So we got the diameter of the biggest circle, and then we get the radius of the teeth circle. So we'll go circle, middle, D. It's 3.375. All right, so this is the lower section for the gear teeth. I'm going to erase that because it's wrong. Circle, D, 5.375. All right, circles back on. Radius now for the bottom of the gear is 2.25, 2 1/4. All right, so this is the top and the bottom of the gear. All right, so my center line, not long enough, but I can extend it. Good. Extend won't extend past an intersection though, so it won't just go. You know, if you wanted to extend it high, like you draw a line and then extend it to the line, but we're good for now. It's extended, everything's even. Then they give us some ideas, right? So what do they give us? They say it's 3/8. The thickness of the gear tooth is 3/8. Across. So that's when I might use my offset. I'll offset a specific distance and I'll do 3/16 because that's half of 3/8, right? And I'll go either way. Okay, so now I have one gear. All right. Let me trim this up again. All right, so I have one gear with the dimensions. Let's do aligned. Take off my snap. All right, I don't think I was on the intersection, but we got 0.375, so that's fine. I just got to measure better. I don't think I exactly hit it. All right, so then we know that there's 360 degrees in a circle, and we know that there's one big and one little gear in each, one out tooth and one in tooth in 15 degrees. So I'm gonna take 360. I'm gonna divide by 15 and hit equals. I'm gonna get 24. All right, so I'm gonna try some stuff. Um, all right, I'm gonna try to explode this. All right, all right. The good things about array, you can modify them later. Let me double check to see if this works. Escape, fine. All right, so yeah. Um, the only thing is we gotta do some trimming. I was trying to avoid. I gotta figure out a better way so I don't have to trim so much. Time is money in these type of jobs, so like I'm gonna Google stuff. I'll probably come back with another video. If you find a better, like, what do you have to do? You have to polar this, this, and this, right? So, however, you could isolate that and then just spin it around on a polar array, you should be good. But I did not. I did a lot of trimming. Not ideal. Um. So what else? What else do we have? Um. 3/8. Our circle's good. Oh, we have to do these. They want us to do a temporary line. Um. And they tell us 15 degrees, 5/8, 5/16 radius, and then another 5/16. Uh, all right, so circle defaults to Oh, not 5, 15. All right, that makes sense. 15 16. That's where we drew this circle. We could have left it. And then we need another one um, with, it seems like the radius is going to be 30. It's twice as big. All right, and then what is it? It's what tells us. All right, so we got 15-degree angle. Doing some math on the calculator. That's not on the screen. Sorry. So just like remember, like double check. Like this isn't anything to do with the drawing, but this is like why some things are true, right? So escape, right? So 112 space 68. They have to add up to 180 if they're next to each other. Now, if they're across from each other, they have equal. So this is going to be the same as this, right? This is going to be the same as this, right? And if you add up any three sides, sorry, those that's always how it works, right? Any triangle, the measure has to be 180. So every triangle, every angle could fit on a straight line. Just some other stuff. This has nothing to do with the drawing. Obviously, like what we would do is think about 15, right? So make a line. Um, doesn't really matter. Tab, space, tab, 15, tab. All right, so 15, enter. All right, so if we do the same logic, um, good. Oh. All right, so this would be the 15 thing, right? So angular. This is just like sometimes I think it's good to like just explain why things are true. 15, right? Space 165 space space. All right, and then we know that up and down is going to be there to there 90, right? So 15. All right, good. So now when we do our angle, our 15 is here. Um, we could draw it the same way, or we could just. All right. So now we got. All right. So now, just to double check, let's do it one more time. Some of this is just like the learning part of it. I'm making a whole bunch of extra lines because sometimes I don't think you guys understand like why things are true. All right, so we're doing some angle measurements. All right, so 15, right? 15, 15, 15. And then if we did the whole thing, the whole thing is 90, right? So that's like the longer way than we had to, but like just to explain, now that we know that the line starts here and it goes 30, so it ends there. So then I can do my trim stuff at 30. All right, so now what I got what I want here, right? I can switch to erase. I don't need all these dimensions. All right, I could probably get rid of this line now too, because I'm going to polar. Array, polar, center point, 4. All right, now I'm gonna close. I gotta do some trimming. All right, let's dimension it out. Um, you do the rest of the dimensions. Also, you got a keyhole that's 1/8 high. You could probably do with a center line. You could offset it half of 1/8 on each side. Nope, sorry, it's 1/4 wide. So offset uh, half of 1/4 is 1/8. So I can 1/8. Good. And then from this, so I'll just turn on tangent. Only tangent, hopefully. And then line. All right. Dimension everything out. Uh, Math wise, that's why we can start dividing things and polaring things. But armature lamination. There we go.